Hi, this is Karen O'Brien, and I'd like to try to complete the infiltration calculator um, discussion by showing you how to use the green Ampt infiltration calculators. So we should start with, let's see, the documentation. So I've maybe already done this documentation, but that's fine. So what we have here is the documentation for version 1, and if you want to get to green Ampt, you go to the widgets. And then here you have the infiltration editor, and that would be the green Ampt right here. So this will discuss the global green Ampt properties, the spatial infiltration using user layers, channel infiltration, the green Ampt calculator for 2023, and the green Ampt processor for the Sergio and OSM databases. So let's just try this green Ampt calculator for 2023, and basically it would just outline what this calculator is going to do and what kind of data that you need, to prepare green Ampt data or green Ampt infiltration data. Like, this is what you need for your projects. If you are working with Maricopa County data, you will use their data that they provide to you. If you are working with your own project and you're not in Maricopa County, you're not in Arizona, you're not in Nevada, then you're going to want to go to this green Ampt method right here, where we download all of the data that's outlined in this method, but we connect to data downloaders and download it automatically. So we're going to show you both of those methods. And as we show you those methods, we'll also be popping into different types of documentation to show you that. So we will start with, let's see, here is the 2018 method, and here's the land use. Let's see what that land use looks like. Okay, so yeah, the land use in the 2018, let's soil here, and then we start with the global infiltration. So you start with setting up the global infiltration, but most of this will be supplemented with the local infiltration. Now, if you hover on top of the labels of these boxes right here, these combo boxes, if you hover over the label of the combo box, you'll see that we have set a tooltip that gives you the name of this parameter, so that you could look it up in the data input manual, and some of the information and instructions from the data input manual. So this would be the global initial abstraction, which if you're doing global, that would be a single value. If you're doing local, it would use the one you use. So we're going to be using a local value or a spatially variable one, so we'll leave that to 0. Soil porosity, this one's something strange here happens. If you're using volumetric soil moisture deficit for d theta, set this equal to 0. So you might want to set that equal to 0 because I think we are using a volumetric d theta. And then this is your average global floodplain hydraulic conductivity in inches per hour. Of course, if you're running a metric model, that would be in millimeters per hour. And this would be a hydraulic conductivity adjustment variable, which you don't really use this unless you are trying to tune in or fine-tune some calibration data. Initial saturation, and that would be representing at the start of the simulation the volume of water over the volume of void. Final saturation would be 1, of course, because you're probably going to completely saturate your area if you're using a 100-year event. Soil suction, or the PSIF, of course, will be replaced by the local PSIF. And the soil depth. Now, I will say one thing about the soil depth is its default is 0. And if you don't set it to something other than 0, it's not going to use the soil depth. So you kind of have to tie the global soil depth has to be tied to the local soil depth. So if you don't assign a global soil depth, it will not apply a local soil depth. So you need to apply this if you want to use it. And then you click OK, and that assigns your parameters. Then the next thing that you can do is you can just click Calculate Green Ampt. But first we take a quick look at some of these shapefiles. Now this is a shapefile that I have modified. I got this shapefile a long time ago from the Flood Control District of Maricopa County, and it had, of course, originally all kinds of data in these fields. I took everything out except what we are going to use. So as a result, this doesn't have any PSIF or D theta in it, and that's the 2018 method. They calculate those from a calculator. So it has rock outcrop, which is a percentage from 0 to 100. That would be your natural R temp, your natural impervious. XK sat in inches per hour in this case, and soil depth. In this case, soil depth is in feet. Okay, and then this would be the parameters that, this would be like the full parameters that are assigned by the Flood Control District of Maricopa County. So they fill in all of the parameters that we'll be using for the 2023 method, where they adapted their older method and they now calculate PSIF and D theta and XK sat and rock outcrops. So what you might see here is, this would be for the whole county, and what you might see here is a lot more data. And it's because some of these are derived variables. Some of them might be like actual variables that are part of the soil data, and like XK sat, and others are derived. So that is the Green Ampt 2023 from Maricopa County. And then this is the 2023 Green Ampt that we pull off of the site. Now this comes from our calculator. And so if you wanted, you could compare the two. All right, so now what we have, okay, so let's focus on a couple of these different methods for a second here. So let's grab, I'm going to turn all of these on so that they're all accessible to the calculator. Now what we can do is we can set up the soil data. Now if we set it up for the 2018 method, we need to uncheck this. And if you're applying your calculator in Maricopa County, you also need to uncheck vegetative cover. Now this one will go to hydraulic conductivity. This one will go to rock outcrop, soil depth, and then you don't have to set these three because the 2018 method didn't use those. It derived them. And now then we'll set this to the land use, and this would become this initial saturation condition, wet, dry, or normal. We won't use vegetative cover, so we can just leave that unchecked. Initial abstraction is here, and that's in inches. And then impervious area is here, R temp. That's your land use impervious area, so parking lots, streets, buildings, things like that. And then you would click OK. Now while that's calculating, I want to show you the technical reference manual, and let's just control home so we can get to the table of contents. And if you come to the table of contents to this method, you'll see the old way that was used to calculate the PSIF and the D theta. So the soil suction and the D theta lookup tables were related to XK sat, and they were calculated by these lookup tables. So we no longer use that for Green Ampt. We now use the 2023 method, which is, let me get back here. I probably could have just gone up. That might have been that might have been fast too. Oh, here we go, is right here. And what we'll do here is when we get to the 2023 method, we'll come here and show you those individual calculators. I'm going to pause this until this is complete, and then we'll come back to it. Okay, so once it's complete, it says the Green Ampt parameters are finished. And then of course you would need to make, if you wanted to use infiltration, you would need to make sure to set it up in your control parameters under the drop down or the expansion window called switches. And you see here that you would be able to set your infiltration switch right here. It's already on because I've done this multiple times. And now what we need to do is export that data. So if I export the .dat files, I will, let's see, Green Ampt generator. This is the Green Ampt 2018. And I don't want to export everything. I'll just export infiltration. Okay, and we're going to come back to that in a few, but before we come back to that, let's change gears and let's show this different method, okay? So now we're going to use the 2023 method, so we can either pick it up off of the Green Ampt Final 2023, and in this case, for the hydraulic conductivity, we'll pick up the XK sat from 2026, the rock outcrop, where did you go? That's adjusted. I don't know how they do their rock outcrop. And the soil depth, oh, it's probably in their documentation though. Their documentation is really good. Okay, where's their soil depth? I don't think they have a soil depth. All right, they don't have a soil depth, so I'm gonna try to set that to one of these guys just to have some data in there. And d theta normal is here, and d theta dry is here, and the PSIF or soil suction is here. So this would be, I think, the soil moisture deficit, soil suction. I don't know what this is. We're just going to use it for soil depth and we'll just ignore that column. Rock adjustment, rock outcrop, that's your natural impervious. Let's see if that makes sure that's the right one. And then of course the hydraulic conductivity. And then the land use stays the same because it didn't change, except that we want to uncheck that. And this time we want to leave this checked, and I'll click OK again. And that's going to start the calculator again. And while it does, let's go to this green Ampt. Again, this is the plug-in technical reference manual, so it's going to talk to you about how it performs each of these calculations. So for the hydraulic conductivity, it's going to intersect the grid, the soil layer to the grid, and it's going to use a log area average to calculate the XK-SAT for each individual grid element. The PSIF is going to be the same thing, like it's just going to use that intersection and apply the log area average for PSIF. The d theta is a little bit different because d theta is partly connected to the soil and partly connected to the land use because of that initial saturation condition comes from the land use. So what we do is we intersect d theta to the land use map to intersect it to the dry, normal, or wet. And then we apply then we intersect that to the grid and apply an area weighted average to the grid. RTemp is also an area weighted average, and except it's an area weighted average over 100 because the Flow2D RTemp is a point decimal percentage. Let me click OK on that and we'll get right back here. Probably doesn't matter. And I think that's it. RTemp, no, one more. There's, okay, vegetative cover. They don't use it in Maricopa County, but it is looks to me like, I'm not exactly sure what vegetative cover does. So XK, it looks like it might be some kind of function of XK-SAT. So I don't really know what it does or how we apply it because I just don't use it. And then initial abstraction is an area weighted average. So it'll just be the initial weighted average coming from the land use layer and over, of course, the the sum of the sub areas over the area of the grid. And that is basically how you will be using the 2023 method. And I think it said it was finished, so let's export that one. So if I click export .files, we can move this to the 2023 folder, and we'll export the infiltration, and then we'll do the final method, which is to apply the download from the Sergio data and the download from the OSM data. So maybe before we do that, we want to uncheck that and then do it. Yeah, that's what we want to do right there. And then this one is okay. So, and oh, another thing I want to do, sorry, let me do this and shut that. Now, some of this data is going to be put in the wrong location. We'll show you when it happens. And so you'll have to move it back. But it doesn't matter because it's all temporary data. Okay, so we're going to take that off. Everything else is okay. Just connect to those and start the calculator. This is going to go online and download the data, and it's going to be loading it in this layer right here. I'm going to pause the video until it's complete. Okay, that one was complete. So looks like it's complete. I mean, you know it's complete because these fields get filled automatically. And then we'll do this one, we'll calculate that one. And again, this is the one where it kind of puts the data in the wrong place. And until we fix that, see it's going right underneath here. So until we fix that, I think by the time you get this plugin, that will be fixed and you won't have to move it. Okay, it looks like that is done. So I'm going to have to click OK, and that's going to start the calculator process. And then I'm going to pause the video until it's done because we don't need to see that happening 3 times. Okay, final time you see here that it says that the green amp parameters are finished, and you can click OK. Now what I want to do now is I want to use the collapse all button, and then I'll expand this, and then let's just move that. You won't have to do this on the final version of the plugin, but I'm going to move that data to the green amp generator because I want it all to be kept together. Now, as you'll note, these are temporary scratch layers. So when you click save the project, it might save them if you allow it to. So let's just see how that works. But you don't actually need them. So if you want to just take these and just get rid of them, and take these and get rid of them and just save these two, that's perfectly fine. We can probably show you that method too. But let's export that infiltration data one more time. And then I want to talk a little bit more detail about that. Okay, so this is the green amp generator. And again, we don't need everything. We just want to compare those data files. And okay, so what I wanted to talk about with the land use layer and the soil layer and the green amp generator is how this works. So Robson created this new methodology, and what it does is he used J.E. Fuller's method of going on to the soil databases and downloading the components you need to get this infiltration data from. So for example, the soil database has all these different tables, like probably 50 or 60 or even 100 different tables that are mostly dealing with like agricultural land and maybe some kind of, oil type of discovery type of stuff. But there's so much data on there that we don't really need. So we pull data from these 1, 2, 3, 4 tables, and then that gets processed into this final data that we get, and we basically do that by sort of tying everything to like a soil key. And I'm not going to go into that whole process, but you can see it, and I talked about it in the documentation video about where you can get the documentation about how all this data was discovered and how they pulled it off of the website for how J.E. Fuller set this up to pull this data off of the Sergio website and publish it for Nevada. So go watch that other video related to documentation if you want to learn more about this. I just want you to know that we are using that method. And then the land use method is Robson's. It's his own idea and it's his own method. So you'll see if you take a look at the land use data from Maricopa County that it's pretty detailed. They put a ton of work into that database, or it's not really a database, it's just it's probably like Civil 3D layers or something, but they put a ton of work into this. And well, that takes a large team and a large agency worth of people to pull this data together. And we know that you don't have those kind of resources. We certainly don't have those kind of resources. So what Robson did is he used the this is the OSM calculator. So the OSM, the OpenStreetMap, is kind of cool, but let me just add one so we can see it. So let's turn these guys off. Okay, so you can see here OpenStreetMap is pretty highly detailed data. It's got pretty excellent street data. It's got pretty excellent data regarding building polygons and things like that. But what it doesn't do a good job of is exporting these streets as polygons. They always come down as polylines, even though they look so wonderful in the OSM map. But then once you download the data, it downloads pretty crappy because the streets come as polylines, and so they don't intersect very well to anything, and you'd have to convert them to polygons to be able to use them. So instead, what Robson did is he downloaded the various layers from OpenStreetMap, and he downloaded them as rasters that represent different types of data. So I'm sorry, but like I can only really guess what these are. Ag is ag land, WATR is maybe open water, but and then I don't really know what land use is. It looks like it has possibly 6 categories, but then he would take the land use layer that is a polygon layer, and he would sample these rasters from this polygon layer to get, you know, like the parameters that you need for the land use. So I would suggest to you that if you're more interested in this methodology, that you just dig into the code, or you go to our documentation to see a little bit about how he set it up, and you dig into the code to see how he's doing this. That would be your best bet on like trying to understand how this works. But it's a pretty sweet method because it gives you, because if you're like looking at the way that you get land use data in the United States from, I think that's the, let's see, is it like the, hold on a second, I think it's the NLCD does land use data, and their land use data is all in like 30-meter rasters, so it's really rough data. So it's perfectly fine for dam breach and like soil sites and things like that, but it's not good for urban because it just doesn't have the RTemp coverage like this good data does. Anyway, so then let me talk briefly about what happens when you hit the save button. So now Robson has set up a new methodology where all of the data in the project is saved to the geo package. So if you wanted to save all of this data to your geo package, you would just hit the save button and all of this data would stay with your geo package. But clearly we don't want all of this data because it's kind of excessive. So I'm going to remove the stuff we don't want and just keep the stuff that we do want. Now I can use a remove layer before you save the data, but as soon as you save the data you can no longer do that. So I want to show you this method. So if I hit save, it's going to ask me, do you want to commit the external layers to the geo package? I'm going to click yes, and then I'm going to have to make some manipulations to the data. So let me pause that until it comes up, unless it happens really fast. No, it's not happening really fast. So I'm going to pause it until it's finished. Oh no, wait, it is finished. Okay, good. But you see what it's done is it's put everything in external layers. So I will take these guys back out to put them back in Green Amp Generator, or you can move them wherever you want, and then the next time you hit save, they'll just stay there. Now if you're using storm drain data, they'll go back into their storm drain group. And I think what I'll do with the Green Amp Generator data is I'll have Robson put that into a Green Amp Generator group. And then I think what we also need to do is when we click Calculate Green Ampt for the OSM data, that we need to have that stay in the right group because it's just going under the top group at this point, and that's not correct. But that's easy. Those are easy fixes, and Robson can take care of that in no time. So that's pretty much the Green Amp Generator. So like maybe the final thing to do would be to come in here and open the infill.dat and take a look at these 3 infill.dat in Notepad++. Let me see, yes, okay, one of them was already loaded. And then maybe we can just, let's see, this one is Green Amp Generator, this one is 2023, and this is the old method that did the old PSIF calculator. And you can see that the new PSIF is pretty significantly higher. This is from the Green Amp Generator, this is from the district's data, and this is the old method. So 0.24, so the PSIF is pretty close. This is your XK set PSIF. I think this might be the D theta. This is the, oh, I'm not really sure why that went to 100. Oh, I know why, because yeah, soil depth is not, we're not using, remember we calculated that from a layer that doesn't mean anything. And then this is your, I think this one is RTemp. Oh, sorry, this is what I want to show you. I actually wanted to show you this in the data input manual. So if you're in the infill.dat tab of the data input manual, it'll tell you what these are. So what we got here is F is the first character, then your grid element number, then your hydraulic conductivity, then your soil suction, then your D theta, then your initial abstraction, and then your percent impervious. But like I said, this has to be from 0 to 0.99 or 0.98 or something like that. And then this is the soil depth. So it looks to me like if we take the green amp generator, and let's just close the 2018 because we don't really care about that anymore. Let's put these two together and see. Okay, so now this is the more accurate soil depth calculator, and this would be that. So ignore this one, it's not any good. And then our other variables are looking really close. So I think that that's a pretty good indication to me that the green amp generator is working pretty good. But here's the kicker. Okay, the Maricopa data has been QC'd by a consultant. Okay, so the green amped Flow 2D data, that the local data that you can get for your own project, you have to QC that yourself. And how do you do that? It's pretty simple. You know, you just come into your soil and land use layers, and you would just, I would suggest, sort these data as high to low to see if these numbers make sense. Like, we don't have any rock outcrop in this project according to our calculator, so you might want to like check that. Soil depth, our calculator's pretty good, but you might want to check that. Maybe you don't agree with it. Now this is in feet. And then PSIF, d theta dry, d theta natural, d theta wet, and then of course we don't use those guys. And then you do the same thing on your land use layer, where you can take and review your initial abstraction, percent impervious, vegetative cover. Well, we don't really use that either. And then your saturation, initial saturation conditions. You can check those out too. And I definitely recommend that you go into Flood Control District of Maricopa County's 2023 hydraulic user guide, I think it's kind of hydraulic guidelines or something, hydrology guidelines, and review how they do their green amp modeling and why they use those parameters, because they have a really good job of explaining what to use in the land use layers and how to set those up. I think I got everything. So this would be the new documentation. Don't forget that in addition to the data input manual, we also have the plugin, the technical reference manual for the plugin. And of course, don't forget to watch the documentation video, because it's going to show you where the green amp documentation is for Nevada and for Maricopa County. And I think that's it. So that should complete the series on infiltration. Video number 1 is called documentation. Video number 2 covers Horton and the SCS curve number, and video number 3 covers the green amp methods. Thank you.